So let me do a more complicated example. Let's take sine squared x times cosine to the power 4. Now, if I want integration by parts, I have to choose those parts. And one part better be integrable. You better know how to integrate that part easily. Can you separate this into product so that at least one of those products is easy to integrate?
Well, we already know how to integrate sine squared.
You know how to integrate sine squared, yes. We can try that. Can you choose something easier than that?
It would be easier to split the sine squared into
Sine squared.
the,
X.
wouldn't it be easier to make it all in terms of one of them using the identity?
You can use identity and rewrite all that in terms of powers of cosine. That we can do that. Well, it will not simplify the problem. It will change the problem of integrating the power of 2 plus 4 with sine and cosine present to the problem of integrating cosine squared times cosine to the 4th, 6th power of cosine. So it's essentially the same problem. So using trig identity at this time, well, to my taste, doesn't simplify. I mean, it makes all the powers at the same place. You have only power of cosine. You can do that. I just don't see big advantage in that. What I'm saying that even after that, you will have to proceed with the same kind of process of integration by parts. And we can as well start it right now.
So the most easily integrable would be either sine or cosine.
Either sine or cosine. Okay, let's try that. What if I make sine the derivative, and then the rest, which is sine x times cosine to the 4th, will be left for differentiation. Okay, well then, derivative of this is going to be a long thing, right? So it's a product, so we apply product rule. Derivative of sine is cosine multiplied by cosine to the power 4th, makes it to the power 5th, and then plus sine of x times derivative of cosine to the 4th, which is 4 times cosine cube times derivative of cosine, which is negative sine. And here, of course, v equals negative cosine. And let's see what we get after that. So we have, well, not an integral first, but the product of u and v, negative sine x times cosine to the power 5th, and then minus an integral of that product that has negative cosine to the power 6, and negative makes it positive, 4 times sine squared times cosine to the power 4. So what do you think about that?
I think that's very much easier.
It's not very much easier. And it will not be very much easier. But it will be exactly the same trick that we play. we consider this as an equation, and we will just have to make that somehow look like this one. And the part of this is exactly what we have, right? Well, can we deal with cosine to the power 6?
We can separate it to its own integral.
Well, cosine to the power 6. Well, remember I was talking about making substitution and saying that this is equal to 1 minus cosine squared times cosine to the power 4, which makes the original integral equal to cosine to the power 4 minus cosine to the power 6. Right? So in some sense, original integral is as difficult as cosine to the power 6. Of course, if you consider cosine to the power 4 simpler. And we should, right? It has less power. So cosine to the power 6 is effectively similar. And what we can do here is to apply the similar, well, the trigonometric identity backward. And say that cosine to the power 6 is equal to cosine squared times cosine to the power 4. And that cosine squared is 1 minus sine squared times cosine to the power 4. And we end up with cosine to the 4th minus sine squared cosine to the 4th. And my first part becomes a sum of something simpler, because it's of degree 4, and again, a part that resembles our original integral. Okay, so let me rewrite it again, getting rid of cosine to the power 6. I have to take care of all the signs, so I'll subtract negative that, negative cosine to the power 4 plus sine squared x times cosine to the power 4, and then plus 4 more of those terms, so I have 5 of those. And now that integral comes with coefficient 5, and therefore it will not cancel with this one. If I use this equality as equation, I can solve for that integral. So if I take that integral to the left, I'll have negative 5 here, so it will become positive 5 on the left, plus 1 makes it 6. Sine squared x times cosine to the power 4 equals negative sine x times cosine to the power 5th, and then plus an integral of cosine to the power 4. And now what I need to do is only to integrate cosine to the power 4.
You can break it into cosine squared of x, cosine squared of x, the integration of parts.
So for the integral of cosine to the power 4, you see that substitution doesn't work because you have only even powers. The power of sine is also even, right? It's 0. So the only way to work it out is, again, integrating by parts. So you have to select the 2 parts. And again, you choose the one that is, well, you do it completely separately, right? You find this integral independently, do integration by parts, choose the part you can integrate, differentiate the other one, And then you will end up again with something similar to what you started with. Either cosine to the fourth, or sine to the fourth, or sine squared times cosine squared. In any case, you will have to use exactly this identity to bring it back to cosine to the power fourth. Use that as equation, take cosine to the fourth on one side, solve for it. You will probably end up there with integral of sine squared, which we already took using integration by parts. So in general, if you think about this process, it is much longer than the process of just taking either u equals sine x or cosine x substitution, right? Because that solves the problem almost immediately. You immediately get rid of any trigonometry. You're left with powers. In this case, what happens is that this integration by parts, and then you solve the equation, reduces that integral to a simpler one. Now, how much simpler? Well, if you notice the pattern here, the simplicity comes with decrease of the total degree. Because what counts here for the difficulty is the total degree, 2 plus 4. Right? The total degree 6 doesn't show up immediately, but if you replace sine squared with cosine squared, you see immediately degree 6. So you start with degree 6 integral, then you do this game, and you end up with degree 4. And then if you do the integration by parts again, you will end up with degree 2. And then if you do it again, you end up with degree 0, which is the end of it. So every step like this decreases degree by 2. And of course, for the test, I will not give you degree 6 and expect you to do all these steps in 10 minutes right, by hands, right? But that's the general pattern. If I give you anything like sine to the 2, cosine to the 2, sine to the fourth, cosine to the fourth, sine squared times cosine squared, you should be able to do either 1 or 2 steps as necessary of integration by parts. Okay? So the only new thing here is not the method. Well, we studied integration by parts already. It's this idea of using equality as equation and noticing that this equation can be solved for one. Yes.
Will you write down what you would do for UV for the by parts for the cosine fourth? So I can see where we go from there. And what would you substitute?
Well, you choose. Well, it's not about substitution, it's integration by parts again, right? So, well, you choose u and v prime so that you can integrate v prime. Well, you see, practically anytime, any way you want. I think any way you choose it, the process will be exactly the same. You will have different formulas, but technically it will be the same process. So if you know how to integrate just cosine, take cosine to the power 3 as u, proceed with the integration by parts, and then at the end you will get something like cosine to the fourth or sine to the fourth. So I don't believe this choice matters, unless you make a crazy choice, totally irrelevant to what you want to integrate. Right? So do something reasonable so that you subdivide this integrand into 2 simpler parts. Because of course you can write cosine to the power 4 as product of cosine to the power 6 and 1 over cosine to the power squared, right? Like secant squared. And that's not really a simplification. So, but as long as you simplify on this step, I think you will be able to proceed and solve, cancel, and find the integral.
Could you use substitution?
Here, you can try, but you will have exactly the same problem we had when the power is even. Right? If you make anything like this, then du will have what, negative sine x times dx, and the sine x is not present here, so you'll have to introduce it. Your integral becomes cosine to the power of 4, which is simply u to the 4th. That's easy, but then you have to multiply by 1 over sine x times sine x dx to make this du. And 1 over sine x is not easy thing about u.
Do it like a tangent, and then you have like a tangent, and then you do like substitution again, and get like a natural law.
Well, yes, you can try different substitutions. If you look at the textbook suggests different substitutions. What I'm thinking right now is that sometimes those substitutions work better than what I'm suggesting, but you will have to figure out on your own when those times happen, right? So what I'm telling you now, and what I was trying to tell you, is the list of simple rules so that those rules work all the time. If you want to apply different rules, there are ways. And I suggest you read the textbook. There are fancy substitutions used there. But then you will have to identify when is it that those substitutions work and when is it that they don't work. Right? And you don't want to go into those. So again, for the purpose of the test, you are welcome to use any substitution, any method you want. If you remember a formula, use the formula. Right? I just don't want to overwhelm you with memorization of formulas. Any other questions?